Hello, 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 hello. Hello, dear students. Welcome back to my YouTube channel. A very good evening to all of you. Just let me know if I'm audible and visible to all of you. Welcome back. So I am audible. One second. Okay. So as you know that today we are going to discuss lecture number 3 of kinematics. Up to now, we had the discussion on definition of kinematics, position, reference frame, types of motion 1D, 2D, 3D, and their examples, distance, displacement, direction, then speed, velocity, and acceleration. So we are done with up to the acceleration part. Now today we will be discussing application of calculus. One second. Okay, so I guess we need to start now, and I hope my screen is very visible to you. Okay, you can see my screen. Okay, so as you know that we are discussing lecture number 3 of kinematics. So let us start now. So let us start with the application of calculus. So application of calculus. Calculus, right? The very first thing is, if we are having xt, xt 1, 2, and 3. Okay, if we are having xt means distance or displacement time, and if we are differentiating it, if we are differentiating it, okay, if we are differentiating it, so this line means differentiation. So if we are differentiating dx by dt, so differentiation of dx by dt, it is velocity. So you will get velocity time. If you are doing then again differentiation, so you will find it is vt. Now we know that a is equals to dv by dt. That means we are getting acceleration time. The differentiation of xt will give you vt, and differentiation of vt will give you at. Okay, or directly if you want to go from xt to vt, sorry, at, there is a one direct method, that is d square x by dt square. It is d square x by dt square. This is what a calculus. So the reverse of it also, that is true. If you are going from at towards vt, then vt to, let us suppose like this, right? Okay, look now, if you are integrating it, integration of a with respect to dt, you will get change in velocity. You will get change in velocity. Change in velocity. That is v minus u. If you are doing integration of velocity, you will get change in position. You will get change in position. Change in position. That means xf minus xi. Or you can write here, look, do you know why? Look, we know that what is acceleration here? So 1 second, beta. You will write here the integration of x dt, this will give you v minus u, and the integration of v dt, and this will provide you x2 minus x1. Nothing more than that. And so on. And so on. Then this was the application of calculus part, basic that you need to keep in your mind. Now let us do some numericals. Based on that thing, we will be having an idea about it. Suppose we are having a numerical. Numerical is x is equals to 3t cube plus 7t square minus 2t plus 3, and this thing is given in meters. Question is, find acceleration. Find acceleration at t equals to 1 second. We have to find out acceleration at t equals to 1. What is given to us? What is given to us? You need to just let me know now what is given to us. Sir, I guess x, look, xt is given to us. We have to find out acceleration a. If we previously look, what is given to us? Sir, xt is given to us. We need to get a. That means we have to differentiate it. We have to do like this now, double differentiation of it. Then I will get my acceleration time. First step, what is first step now? 1 second. What is first step now? Look here. First step is, I will write dx by dt. Differentiation of 3x cube, it will be 9t square. This differentiation of 7t square, it will be 7 to the 14, 14t. Minus 2. Second differentiation of it. This is velocity. Then second differentiation of it. That means dv by dt. V is equals to d square x by dt square. This will give you the acceleration part. It will be 9 to the 18. It is 18t plus 14 only. But we need acceleration specifically at t equals to 1 second. I will put the value, that is 18 into 1 plus 14. So my answer came out to be 18 plus 14. 8 plus 4, 12, 2. It will be 32 meters per second square. This is my required answer. I guess very easy, no? Extremely easy, very easy. Okay, second numerical. If my position is given to me, position means vector, na r vector. If r vector is given to me, and that is 2t square I cap plus 3t j cap plus 5k k cap meters. First thing that we need to find out, velocity at t equals to 1 second. Second thing, speed at t equals to 1 second. Third, acceleration at t equals to 1 second. For velocity, how to manipulate now this equation? How to manipulate? So I can write dr by dt, no? Simple, dr by dt. I will write 2 to the 4, it is 4t I cap. Plus it will be 3 j cap only j cap. Plus 0, 0. I need t equals to 1 second, put it value now. So I can write velocity came out to be, it is 4 into 1 I cap plus 3 j cap. It will be 4 I cap plus 3 j cap. This is my required answer. This thing is my required answer. Now I need to find out now. What I need to find out? Sir, we have to find out now speed. Speed. What is speed? I guess speed is the magnitude, right? So look, velocity is given as 4 I cap plus 3 j cap. So the mod of velocity will give the speed, that is 4 square plus 3 square. It will be 16. 16 plus 9, that is 25. So my answer came out to be 5. It is 5 meter per second. Yes, so it is 5 meter per second. Now, if we want to find acceleration is nothing. It will be dv by dt. dv by dt. Acceleration d by dt. And velocity is 4 I cap plus 3 j cap. Done? No, it is 4. It is sorry. It is 4 t I cap. Sorry, beta g. It is 4 t I cap. It would be 4t I cap plus 3 j cap. So acceleration is equals to only 4 I cap plus 0. So the acceleration is equals to 4 meter per second square. And you can see here acceleration is constant. Acceleration is constant. If somebody will tell you what is the direction of it, look, direction. I cap, j cap. So it is like this, theta, I is 4, and my j is 3. So tan theta is p by b. P is 3, b is 4, it is 3 by 4. So theta is equals to tan over 3 by 4. And 3 by 4 it is 37 degrees. So theta is equals to 37 degree north of east. It is north of east. Done? One more numerical. One more, a good numerical now. We are having a function. Function is t equals to under root of x plus 2. Done? Find time. We have to find out find time. When velocity becomes 0. When velocity becomes 0. Okay. So look, velocity means dx by dt. But here we are having tx now. So how to get t now? Sorry, this x now. Can I write now, is it root x equals to t minus 2? Okay, sir. The squaring both sides, I will square this one. And I will square this one also. I will get x equals to t square plus 2 square minus 2 into t into 2. So x came out to be t square plus 4 minus 4t. Now I can apply dx by dt. dx by dt. This is my velocity. And my time, it would be 2t plus 0 minus 4. So my velocity came out to be 2t minus 4. Done. And it states that I need the time where my velocity becomes 0. So put the velocity as 0. So I will get 2t minus 4 only. So therefore I can write 2t equals to 4. So t came out to be 4 by 2. So I can write here t is equals to 2 seconds. Easy or very easy? Easy or very easy now? Easy? One more numerical. Look, the numerical that in pattern we are in some PYQs also. PYQs of NEET and JEE also, right? I am teaching you some concept, then some basic numerical, then some PYQs of it also. The NCERT numericals also. That's why I am giving you the bulk of numerical practices, right? Suppose x equals to t cube minus 3t square plus 5 meters. Find velocity. We need to find out velocity when my acceleration is 0. I need to find velocity when my acceleration is 0. So what is the meaning of it? Look, velocity simply means dx by dt and acceleration means dv by dt, or I can write d square x by dt square. Look now, what I can do right here now, I can write dx by dt equals to, it will be 3t square minus 6t. Now it is velocity, so velocity came out to be 3t square minus 6t. Now velocity is a function of time, so I didn't get the value of it. To get my value, we are having one more thing, that is acceleration. So acceleration is equals to dv by dt. So I will write d by dt 3t square minus 6t. So acceleration is equals to, it is 6t minus 6. Acceleration is 0, so it is 6t minus 6. 6t equals to 6. So t came out to be 1 second. 1 second. Therefore, my velocity is equals to 3 into 1 square minus 6 into 1. So velocity came out to be 3 minus 6. Velocity equals to minus 3 meters per second. Done? Easy or very easy? Easy, no? Okay. Now one more numerical. One more numerical. V is equals to x square plus 1. Done? Find acceleration. Find acceleration at x equals to 1 meter. Okay. Now this numerical is very different from the previous numericals. Do you know why? Look. Because velocity is equals to dx by dt and acceleration is dv by dt, or you can write here d square x by dt square. You need to find acceleration from velocity. You need to find acceleration from velocity. But you cannot apply this formula. The reason being is, look, here the velocity should be function of x. So function of t. That means velocity, let's suppose it is 2t square plus 2t. So you can write now, you can write dv by dt only if here is t present. If here is t present. Now you can see here t is not present, x is present. So we are having one more formula for acceleration. That means v equals to dv by dx. This formula is second one for acceleration. Yesterday we done it, no? Look here now. So I can write dv by dx and it came out to be, it is 2x only. So what is acceleration now? So it is v dv by dx. Simple. What is v? V is x square plus 1. And what is dv? It is 2x. A. But I need acceleration especially at when x equals to 1 meter. I can put 1 square plus 1 into 2 into 1. I can write here 1 plus 1 into 2. Then it is 2 multiplied by 2. Therefore, my acceleration came out to be 4 meter per second square. It is 4 meter per second square. Look, we are doing varieties of numericals. We are doing a varieties of numericals. Okay, we are not doing a simple one type of numericals, right? This was a different. Now let us do a different numerical now, a different one to apply different formula. Question is particle starts from rest. Question is particle starts from rest. Starts from rest means my initial velocity is 0. From origin means 0, 0, 0, 0. If let us suppose we change this numerical, let us suppose we change it now. We are having the rest now. Let us suppose we change it now. We are having some different now. Let us suppose. Tough one. A particle starts from origin. Let us suppose from origin. From origin. With velocity v, and v is function of time v t square meter per second. Find out displacement. Find out displacement in first 3 seconds. In first 3 seconds. Done? Okay. So look, what is given to us, sir? If we can see here, my velocity is given to me. Velocity. And what we have to find out? Displacement. Displacement. Okay. That means I can write displacement is equals to integration of velocity with respect to time. Done? Integrate from 0 to 3, velocity is equals to t square then dt. Done now? Okay. So what is t square? It came out to be t cube by 3. Upper limit is 3. Lower limit is 0. I can write 1 by 3. Then multiplied by 3 cube minus 0 cube. So displacement equals to 3 3 is 9 and 20. It is 27 by 3. 3 1 is 3, 3 9 is 27. So my answer came out to be 9 meters. So displacement is 9 meters. Easy or very easy? Done? Okay. Look now. We are having a topic known as acceleration with velocity. Acceleration and velocity. Suppose, case first, if angle between velocity and acceleration is acute. Is acute. Acute means when theta is less than 90 degree. Okay? Or they are parallel. Or they are parallel. If my velocity and my acceleration is parallel, so what will happen now? Speed increases. Speed increases. Look now how. My velocity, acceleration. This angle means theta angle. So now what we can do it, look now. Acceleration, we can do two components of acceleration. This could be a cos theta and this one will be a sin theta. This acceleration is parallel acceleration. This one is perpendicular. Perpendicular. and we know that velocity acceleration which is perpendicular to velocity, it is only used for direction change. Direction changes. So a cos theta is responsible for direction change, and parallel component is responsible for magnitude changes. Magnitude changes. Increases or decreases? Look, if velocity and acceleration both are in same direction, so you were right, sir, speed increases. Speed increases. But I need a 1 second from your end. 1 second. One second, 1 second. Now we are back. Okay. Look now. So case number second. Case number second. If my angle is more than 90 degree, obtuse angle. If angle between velocity and acceleration is obtuse, that means if theta is more than 90 degree or anti-parallel speed decreases. You know why? Look, if velocity is going in this direction and my acceleration is going in this direction, then look here, this theta is more than 90 degree. It is one component will be along this direction, and one component will be along this direction. Then this is perpendicular component. This one is perpendicular component, and you know what now, perpendicular component is only responsible for direction change, and this one is my parallel component, and parallel component is responsible for magnitude changes. Then look, direction of acceleration and the direction of velocity both are opposite, so this is a pure case of retardation. That's why speed decreases. Third case. Case number 3. If angle between velocity and acceleration is 90 degree, that means if my velocity is going in this direction and my acceleration is in this direction, then so you can do one thing only. Look, only perpendicular one is present. So in this way what will happen? Only direction changes. So if the angle of velocity and between velocity and acceleration is 90 degree, so what will happen? Only direction of your motion will change, magnitude will remain same. So you can write here, no change in speed. In this case, there is no change in speed. Only direction changes. Only direction changes. Done? Easy or very easy? Okay. So I will be giving you one numerical. Then we will start equation of motions, right? Look now. We are having a numerical. Numerical is x equals to 4t square, y equals to 2t. Find it is shape, it is geometry, it is shape. Straight line, ellipse, circle. We have to find, no? Hello, beta. We have to find its shape. Okay, how we can do it? What is x now? Sir, x is equals to 4t square. What is t from here? Sir, t is equals to y by 2. So you can write x is equals to 4. It is y square by 4. 4 cancel out. So x is proportional to the y square. If x is proportional to the y square, you can write it is a parabola. Parabola. You know it, na? X is inversely proportional to the y. Hyperbola or rectangular hyperbola. It is proportional to y square. It is parabola. If y equals to mx plus c, that is straight line equation. Done? So I will be showing everything now. If you are making a short notes, so what do you need to include now? Look like, just write like this. Write like this. Acceleration, two types. If my acceleration is 0, it indicates my force is 0. If my force is 0, so my velocity is constant. Velocity constant means both magnitude as well as direction is same. So it will go along a straight line. Okay, so you will write here, sir, magnitude as well as direction remains same. It will be straight line motion. Straight line motion. When my acceleration is 0. Done? Okay. If my acceleration is not 0, that means my acceleration is present. My acceleration is present. So now there are two types of acceleration present. One is if my acceleration is constant. If my acceleration is constant. Second one is if my acceleration is variable. Variable. If my acceleration is constant, so look, if my velocity and acceleration is in same direction, so you can write it is a straight line motion, straight line, and it is speed up. Speed up. If my velocity and acceleration both are opposite to each other, still motion is straight line motion, straight line, but it is speed down, retardation. If my velocity and acceleration both are acting at an angle theta, acceleration is constant, so the path will be parabola. Path is parabola. Parabola. You know what is parabola? Look, this is my parabola. Done? If you are making short notes now, just make this diagram now. It will be giving you the previous 4 to 5 slides, nutshell things. Okay. Now look. And if acceleration is variable, that means any curve is possible. Any curve. Any curve. It is not constrained. It is not fixed. Any curve is possible. But the most important one is this one. Most important one. You will get 99% numerical based on this particular thing. So let us start equations of motion. Let us start now. Equations of motion. And one of the most important things that you need to remember, equations of motion is only valid, only valid, only valid when my acceleration is constant. When my acceleration is constant. So it will give you a one clue. The clue is whenever your acceleration is constant, you can apply the equations of motion. Okay. U means initial velocity. U means initial velocity. Initial velocity. V means final velocity. Notation, right? V means final velocity. T means time. S means distance or displacement. Distance or displacement. So we are having two things. One is scalar form. One is scalar form. One is vector form. Vector form is not important, but scalar one is important. First equation. V is equals to U plus AT. It is vector form. V vector equals to U vector plus A vector T. Second one. S is equals to ut plus 1/2 of at square. It is vector form is S vector equals to u vector t plus 1/2 of a vector t square. Third, v square equals to u square plus 2yas. It is vector form is v vector dot v vector equals to u vector dot u vector plus 2 times a vector dot s vector. These are some equations that you need to remember. Only scalar form is important, right? Only scalar form is important, not the vector one. Only scalar one is important. And we are having some more equations, that is s nth. Nth means that suppose someone will ask you find the displacement is fourth second. Fourth, not in 4 seconds. Look, 4 means if you are noticing from first second to 4. Fourth means the 1 second gap. The 1 second gap. It is Snth. Snth means u plus 1 by 2 a to n minus 1. V average. Average velocity magnitude. Okay. It will be u plus v by 2. Constant acceleration. What is S? Distance or displacement, u plus v by 2 into t. These are most important formulas. If you can open your PYQs, na, you will find numericals based on these two formulas, this one and this one. You need to have these formulas. U initial velocity, v final velocity divided by 2. Now, sir, we are done with all these formulas. Let us do some numerical practices. We are having time now. We are having 1 hour, right? Let us do numerical practices. Okay. First question is, my initial velocity is 2 meter per second. My acceleration is 5 meter per second square. Find out velocity and my displacement. Time is given as 2 seconds. 2 seconds. Okay. So velocity we have to find out, acceleration and u is given. So what, I guess v equals to u plus at. I can use this equation. So we have to find out u is how much? U is 2 plus a is 5, t is 2. So v came out to be 2. 5 2s are 10. I guess v is 12 meters per second. Yes or no? Yes or no? Easy. Now second one, s. What is s? Look, s equals to ut plus 1/2 of at square. Okay, s. What is u? U is 2, t is 2 plus 1 by 2 into a is 5. It is 2 multiplied by 2. 1 to cancel out. So s came out to be 4 plus 5 to the 10. S came out to be 14 meters. One basic numerical, how to apply these formulas. One of the basic numerical way. Done? Okay. Now I will make you understand what is different. What is the difference between Sn and Snth? Okay, look now. If I will give you a numerical, that is, a particle starts from rest and acceleration is constant, that means 4 meter per second square. So what we have to find out? We have to find out S2 and we have to find out S second. S2 means find the displacement in 2 seconds. First second plus second second. So what I can write here, I can write in simple definition, ut plus 1 half of at square. What is u? U is 0, t is 2 plus 1 by 2, a is 4, t is 2, t is 2. Cancel out. So I can write here 4 to the 8. It is 8 meter. But this one, it is Snth. Snth means it is u plus a by 2, 2n minus 1. U is 0. So what will be S second? A is how much? It is 4. It is 4 by 2, 2. What is n? N is second. Second minus 1. How it is second? It is second. So 2 ones are 2, 2 twos are 4. I can write here 2, 4 minus 1. So it is 2, that 3, 3 twos are 6 meter. A difference between Sn and Snth. Done? Easy or very easy? Okay, one more numerical. Numerical like that. Particle's initial velocity is given as 20 meter per second. Acceleration is uniform and it is not given to us. Uniform on a straight line. That is constant acceleration. After 2 seconds, velocity becomes 40 meter per second. Find S. So how to find S now? Okay, so can I write V equals to U plus AT? This formula I cannot apply. S equals to UT plus 1 half of AT square. Look, acceleration is uniform but not given to us. Okay, so we can do one thing now. What is acceleration? Is it change in velocity by time t? Yes. Acceleration. What is delta V? Is it 40 minus 20 divided by 2? Yes. Is it 40, 20, it is 20 by 2? Yes. Is it 10? Yes. So my acceleration came out to be 10. Okay. So S. What is U? U means 20. 2 plus 1 by 2 into 10 multiplied by 2 into 2. Cancel out. It is 40 plus 20. 60 meter. It is a lengthy process, right? A lengthy process. Firstly, we have to find out A, then place the A in this formula that we will get the answer. We have a short trick, na? S equals to U plus V divided by 2 multiplied by T. Shortcut. What is U? U is 20. V is 40 divided by 2 multiplied by 2. Cancel out. Answer is 60. Not 600, na? 60. Okay, one more numerical. Be quick, na? Be quick. One more numerical. Particle's initial velocity is 10 meter per second. It covers distance 300 meter. Then its velocity becomes 20 meter per second. Find the time. Sir, if A is constant, simple. What? S equals to U plus V divided by 2 multiplied by T. Okay, S is 300, U is 10, V is 20 divided by 2 into T. So it is 300, 30 by 2 into T. Cancel out. Then it would be 3 to the 6 or 3 1 3, 3 1 3. It will be 10 equals to 1 by 2 into T. So t came out to be 20 seconds. 20 seconds. Okay, look now. Now we're having a numerical. Or let us start a new part, right? A new part. And new part is known as graphs. Start a new part known as graphs. Important. So we are having xt graph, we are having vt graph, we are having at graph. These three graphs we are having in our syllabus. First, we will start with xt graph. xt graph. Okay, xt graph. First one. Look now. We are having six graphs like xt graph. Six graphs. First graph. First graph, beta. Yeah, xt or st both are same. xt. If my line is going in this way, look, it simply indicates slope. What is dx by dt? Dx by dt means velocity. You can see here dx by dt, velocity, and velocity is 0. That means the particle is at rest. If the particle is at rest, so its graph looks like this. Rest now. If it is like this now, look. Like this. Look here, theta. Theta is less than 90 degree. xt. Theta less than 90 degree. So what is slope? Slope is tan theta. Tan theta is less than 90 degree. That means my slope is positive. If my slope is positive, you can write my velocity is positive. Velocity is positive. And look, slope is constant. So my velocity is constant and positive. In xt graph, if we are having straight line, that simply indicates my velocity is constant. My velocity is constant. So what about acceleration? If velocity constant, so acceleration must be 0. Must be 0. Third graph, if it is going like this now. So I will make it like this. Look now. What is theta? Look at theta. Theta is more than 90 degree, and tan theta, which is more than 90 degree, is equal to negative. So my slope is negative. Slope is negative. If my slope is negative, so you will write my velocity is constant. Velocity is constant. That is, yes, velocity is constant, but my velocity is negative. Constant but negative. What is acceleration? If velocity is constant, so acceleration must be 0. You need to remember each and everything. Okay, if particle is at rest, so my line should be passing through where my angle is 0. If my velocity is constant and positive, it should going upwards, theta less than 90 degree. If my velocity is less than 90 degree, sorry, if my velocity is more than 90 degree, that means my velocity is constant but negative. Negative but constant. It should be decreasing. And in both the cases, my acceleration is 0. Why? When my velocity is constant, velocity constant means no force is there to change the velocity. That means my acceleration should be 0. Okay, one more. like this xt. How to do it? Look, take this point, and take a tangent. Look, theta is less than 90 degree. Here one more. Look, theta is less than 90 degree. That means velocity is positive. Velocity is positive. Is it constant? No. Look, velocity, that means slope is positive, but slope is decreasing. Slope is positive, but slope is decreasing. Now tell me, is there any factor which is decreasing slope? Okay, that means velocity changes. Okay, so what factor changes velocity? Sir, acceleration. Okay, velocity decreases. Now look, here slope is more, here slope is less. That means velocity decreases. So I guess if velocity needs to be decreasing, so the acceleration direction should be opposite to velocity. Look, velocity is positive, so acceleration needs to be negative. So velocity positive, acceleration negative. Then only my velocity will decrease. Easy now? Okay. One more. Like this. xt. Okay. Take this part. Take this part. Draw a tangent. Look, theta. Theta is less than 90 degree. Positive. One more. Here. Theta less than 90 degree. So you were right here. Velocity is positive but constant. Sorry, not constant, but it is increasing. If velocity, that means there should be acceleration also in positive direction. Positive speed up. Positive speed up. One more like this. Like this. Look, first point, second point. Done. Take a tangent. Take a tangent now. Take a tangent. Look now. Theta 1, theta 2. Done. So what you will see now, look, xt, theta is more than 90 degree, so velocity is negative. Velocity is negative, but it is increasing. You know that this graph is increasing graph. Increasing graph. That means acceleration needs to be negative. Why? Negative, speed up. So now, what you need to remember now, that is, look now, that is, particle is at rest. This one. A particle is at rest, line should be like this. If acceleration is 0, if my acceleration is 0, so my line should pass like this. Just remember it. One more case, that is, if my velocity is negative, constant, but acceleration is 0, so this case. If my velocity positive but decreasing, so this case. If my velocity positive but increasing, this case. If my velocity negative decreasing, sorry, increasing, this case. Okay, look, you need to keep this thing in your mind now. Why? Because at the end, when we are doing conversion of graphs, okay, if xt graph is given, we have to find vt or xt graph. If xt graph is given, we have to find at or vt graph. Then we need to apply these points. So I guess we are done with xt graphs, right? I guess we are done with xt graphs. Okay, let us do one numerical then, and one simple numerical. Okay, look now. If we are having a graph like this, So my graph, point A, B, C, D, and E. Give me the sign of velocity at A. Is it positive, negative, zero? What is the velocity at A? Sign. I need only sign. Positive. Yes, it is perfectly positive. Why? Positive is if you are just making a tangent, so theta is less than 90 degree. What is velocity at B? Positive, negative, zero. Done, beta. You're correct. Velocity at B, positive, negative, zero. In the same way, velocity at C, velocity at D, velocity at E. Perfectly. Velocity at B is zero. Why? Because straight line, zero. Done perfectly. Now C. What is C now? C is a tangent. More than 90. More than 90. So, negative. Perfectly. What is D? Sir, zero. What is E? Positive. This is a PYQ. So, a PYQ. D is zero. Why? Because you can find this line, a straight line. Straight line means zero. Look, straight line means zero. Okay, now velocity time. Velocity time and the slope of velocity time is acceleration. One, two, three, four, five, six graphs. Same. First line in this way. Velocity time. Velocity time. Velocity time. Velocity time. Velocity time. Velocity time. Okay. Second one, like this. Third one, like this. Fourth one, like this. Fifth one, like this. Last one, sixth one, like this. We are having these six graphs. Now we need to think about these graphs. Okay, look here. I guess here you can write theta is 0 degree. So tan 0 is 0. So my acceleration is 0. If my acceleration is 0, so my velocity is constant. Look now, here my theta is less than 90. So my acceleration is positive and constant. Positive and constant. and my velocity also positive. You can see now my velocity is also positive. But if you are good with some chapters, no, definitely you can qualify JEE. There is nothing that is impossible. But if you are very dedicated towards your syllabus, if you are very dedicated towards your everything, I am giving you the good content. Na? You can compare my content with other teachers. I am giving you the perfect content. But it is up to you now how you can utilize these contents. You are watching like a movie, you are like watching like a film or web series, or you are doing these numericals. You are getting something in your mind. You are not wasting your time. If you are seriously dedicated towards your time, then definitely you can do it. I qualified myself JEE in 3 months, right? You can also do qualify your examinations. Okay, this one here. Theta is more than 90 degree. So that means my acceleration is negative, but sure it is positive. And constant. Acceleration is negative, but constant. But what about velocity? What about velocity? Sir, velocity is positive. Now look, acceleration negative, velocity positive. Direction is opposite to each other. So what do you will write? Speed up or speed down? What do you will write? Speed up or speed down? That is good, no? That is good. I am giving you the perfectly content. Okay? Because I myself qualified examinations, no? Each and everyone. That's why I know now. Right from there, just giving you the numericals, right? And JEE is very simple one. Done? Is it speed up or down? Okay, acceleration negative, V positive. Both are opposite, so speed down. Speed down. This one, this one. You can see now, look, same theta 1, theta 2. We know that theta 1, theta 2, both less than 90 degree. So my acceleration is positive. So my acceleration is positive. But look, it is decreasing. It is the rate is decreasing. Rate is decreasing. Rate is decreasing. Rate is decreasing. So my velocity is decreasing. Meaning is, let us suppose you are walking. I am pushing you a very great extent. By my push, you are walking, right? Now I take my hands off. You still will walk, but your speed will be less. That is the reason of this graph. Yes, look, V is positive. Yes, V is positive. A is positive. Both are positive. But rate of A is decreasing, right? Due to this rate, my V will decrease. Now here, what do you write here? Theta 1, theta 2. Theta 1, theta 2, both less than 90 degree. So my velocity is, sorry, my acceleration is positive. Velocity is positive. Speed up or down? Speed up. At any angle, at any angle. We need to compare 2 points, right? If we are having any curve now, we need to compare any 2 points. Any 2 points. Let us suppose you will compare now. Let us suppose you will compare these two. Look, you will compare this point and this point, or this point and this point. Okay, you can get your answer. It is not compulsory that you will take my these 2 points. Not compulsory. Look here, velocity is positive, but you can see, look now, theta is more than 90. Theta more than 90. That means A is negative. A is negative. V is positive. A is negative. Now last graph. Last graph, that is acceleration time graph, then we are done with graphs, then we will do manipulation of graphs. And if time, then we will do, right? Okay, we are having 24 minutes left. Look now. We are having now acceleration time. And you know that dA bata dt, it is not defined. It is not defined. But integration of what? Integration of A with respect to dt, it will give you change in velocity. And this is area under curve. Area under curve. So, first graph, T A. What this line indicates? Constant acceleration but positive. What this thing represents? Constant acceleration but negative. What this thing represents, beta? My acceleration is variable. Beta, if you have not watched my previous lectures, go to the basic mathematical calculations. Okay, do one thing, go to the live session. There I have given a one short video on basic mathematics. Just watch that full lecture. You will find how this graph is increasing, decreasing, how to compare 2 points there also. Okay, so we don't have that much of time, so I will just explain each and everything to you in the lecture, right? Look now, I will compare each and everything now. I will compare each and everything now. Look now. Condition. XT graph, VT graph, AT graph. At rest condition. That means my x will be constant. And if my x is constant, so v is 0, so a is 0. Okay, make a graph. T x graph will looks like this. If we are doing VT graph, my v is 0. If my v is 0, so it will go like this. On this way, right? Third graph. AT graph. AT graph. A is also 0. So A will looks like this. Okay. Second condition. Second condition. Second condition. Uniform motion. Second condition, uniform motion. That means my x is increasing uniformly. If x is increasing uniformly, so v should be constant. If my v is constant, so my a should be 0. My a needs to be 0. So I will make a graph. Uniform, right? So you will write like this. XT. You can see here theta is less than 90 degree. So dx by dt is v. So v is constant but positive. Positive. So x is increasing. So here a is 0, v is constant. I guess that line was like this. So you can write here dv by dt is equals to 0. That means acceleration is 0. If my acceleration is 0, so the graph will look like this. You will compare it like this, na? So last time we done it na separately. Now here we are comparing xt, vt, at. Done. Third graph now. Third type. Firstly, I will make the graph firstly, then we will proceed. Condition xt, vt, and at. So we are having condition now. Condition xt, vt, at. Now it is linearly increasing. Linearly increasing means x is increasing, v is also positive but increasing, but a is positive but constant. Look now, tx linearly increasing means this graph, t v is positive and increasing, the graph will looks like this. T and a is positive but constant, that would be like this. So this graph is equals to this graph, and this graph is equals to this graph. Look now. So what we are having now? Linearly decreasing. Linearly decreasing. X is increasing. V is positive, but V is decreasing. That means A should be negative but constant. Look here now. T, X increasing, V is positive, decreasing. I guess that graph is like this. Velocity, 1 second, positive, A is negative. I guess that is like this way, TV, and A is negative. This is T, A. This is my minus A. Easy beta or super easy? Okay, if this is very easy to you, now we can do some numericals. Then you have to convert those numericals. Look now. So what is given to us? Acceleration time graph is given to us. Think about it. Acceleration meters per second square, time second. So I have to make each and everything in detail now. So I'm making the graph now. Okay, it's my graph. Akash Kori beta. Yes, if you have doubt, you can ask me, na. If you have a genuine doubt, you can ask me. So now we have to make a graph of VT. I will extend it now. Look. VT, then XT. Then XT. Look here. X, this is VT, then XT. Look now, here velocity is constant. Velocity, no, sorry, here. Acceleration, now, this one, acceleration is positive and it is constant. So what will be velocity time? Look now here, look. Acceleration is constant. Look, positive constant. What is velocity? Velocity will be straight line from origin. Okay, so you will write, so it is velocity. It is velocity will be straight line from origin. This will be velocity. Sorry, I will change the color firstly. It will be like this now. Done. Okay, then second point is my acceleration is 0. What about my velocity? So my velocity will be constant. So my velocity will be constant like this. Third case, here also my acceleration is negative but constant. What will be my VT? It will be decreasing, no? So it will be decreasing graph here. Decreasing. It will look like this now. If we talk about now XT graph, okay? We'll change the color firstly, XT graph. So look here, velocity is increasing, or look, acceleration is constant, velocity is increasing. So what about my XT? It will be increasing. It will be increasing in this way. Now my velocity is constant. So that will go like straight line like this. Velocity decreasing, that will go like this. Okay, this one is like this, straight line, that this one is like this. Done. This is how you need to change your graphs. This is how you need to change the graphs. Okay, you are saying me how it will increase. Look now, for this case now, look, acceleration is positive and constant. Done. And velocity is positive but increasing. Look here now. Look here now. Acceleration is positive and straight line. Velocity is increasing. Okay, so my x will be increasing in this way. So you can see it will increase like a curve. That's why I give you a table now. Look, that's why you need to remember this table. You need to remember this table. When and what will be the parameter of it. You remember it. Okay, second numerical. Second one. Time. If my velocity time graph is not given, one like this, second like this, third like this. Now we have to make xt. xt. Velocity is increasing. So my x will be going in the curve like this. Velocity is constant. Velocity is constant. So it will go like this. Velocity is still increasing. It will go curve like this. Third one, 80. 80. 80. Velocity increasing. So my acceleration is constant. Velocity constant, acceleration is zero. Velocity increasing, acceleration is constant. This is how you need to change your graphs into xt, into vt, into at, and vice versa. Done? Easy? Okay, let's do a numerical more. If we are having a graph like this, if we are having a graph like this, twenty, 40, 2, 4, 8, t, x. Now, displacement in 8 seconds. Displacement in 8 seconds. So my displacement equals to final minus initial. You can see finally it is at 0. So you can write 0. Minus initially at 20. So minus 20. So it is equals to minus 20 meter. If somebody will ask you distance, find distance. What is my distance? Look here. It was at 20. Then go to 40. So it is 20. Now from 40 it goes to 0. That means from 40 it goes to 0. It is 40. Equals to 60 meters. Average velocity. It will be distance by time. Displacement, sorry. Displacement is 20, or you can write 20 also. Now 20 by t. T is how much? 8. It is 2.5 meter per second. Done? If somebody will ask you velocity at t equals to 1 second. 1 second will be here. That means I need the slope of this triangle. So what is tan theta here? Is it 20? 20 by 2? That means 10. So my velocity is equal to tan theta. Tan theta is equal to 10. Easy or super easy? Easy or super easy? Yes, beta, you can ask me. Yes. No, look here. We have to find out velocity mod. It is displacement by time. So look, what is velocity? Displacement by time. What displacement is 20 by t, that is 8, 2.5. No, final velocity means at the final, no? It is not at 2. So if you can see here, you can tan theta. Look, final velocity, it is v final. So what is v final? That is tan theta. But which tan theta? That will be this tan theta, no? This one. Final end. Look, what is this 40? This 40 simply indicates 40 meter. This is 20 meter. It is meter. It is xt graph. You can see it is xt graph. If we need velocity, we have to differentiate it. We have to do tan theta things, right? Take a minute, just understand the whole scenario, then ask me doubts. You're most welcome. So I will give you one homework numerical and then we can wrap up the session. One homework numerical. First thing, displacement in 4 seconds. Second one, distance covered in 4 seconds. Third one, average velocity in 4 seconds. Fourth one, velocity at t equals to 3 seconds. Okay, this is your homework numerical and I guess you can do it. And tomorrow we will start from graphs, doing 2-3 numericals from graphs. Then we will start motion under gravity. That will take 2 days and chapter is gone. Easy, no? So how many topics are left now? How many topics are left now? Only one topic. Motion under gravity. This will take 2 days. 2 and that is 3. That is four. It will take 3 more days. 3 more days. And complete chapter. From Monday, we'll start 2D. Same. My timing is same. When I was with the different company, so I was taking class at 10:30, right? Night. But now I am only taking the YouTube classes and my private classes. So my class is 8 p.m. Do share the lecture, right? And if you find anything interesting, no, just ping me a comment, right? That's all from your end. And if you want to ask me anything, you're most welcome. I have given my Telegram link in the description part. You can go there and just give me some things, right? 1 second. So now I'm making the PDF file so that I will just share this PDF file in my Telegram group. There you can just get these notes. Okay. And thank you, beta. Thank you. सर वन डाउट आलू खाओगे? एक मिनट, आप पढ़ने वाले बच्चे नहीं हो. Thank you, beta. Bye. Good night. Take care.